Here we go. Got a couple more example series convergence questions. Let's start out with this one at the top. So first of all, I'm going to factor out this 4. Okay, so if I factor out a 4 here, that's going to give me the series 1 over n minus 3 multiplied by 4. But whatever 1 over n minus 3 does is going to do the same thing if it's multiplied by 4. Notice that we can compare that to 1 over n. Okay, and by the way, n does start out at 4, so we don't have to worry about zero denominators or negative denominators or anything like that. If you remember, 1 over n is the harmonic. Okay, that is divergent. We have a series here in which the denominator values are smaller. Remember, fractions with smaller denominators are larger. So the terms of this series are larger than the terms of the harmonic series. Okay, if we have a series that adds up to infinity, and we've got another series that has terms that are greater than or equal to the terms of the series that adds up to infinity, its terms are also going to add up to infinity. So this is a divergent series, and that would be by the comparison test. All right, number 2. We've got this 2 over radical n times quantity n plus 4. Well, once again, I'm going to factor out a 2 here, and I'm going to rewrite that denominator. Okay, I'm going to rewrite this as 1 over. Remember, radical n is the same thing as n to the 1/2 power, and I could distribute that through. That's going to be 1/2 times n to the first is going to be n to the 3/2 power, okay, or n to the 1.5 power plus n 4n to the 1/2. Okay. Anyway, if you notice here, n is always positive. So that 4n to the 1/2 value is always going to be positive. This can be compared to a p series with an n value greater than 1. You can compare it to 1 over n to the 3/2, okay, which is going to be convergent. And because n is always positive, we're adding positive values on the denominator. We've got a fraction with the denominator that's bigger than the terms of the fraction we're comparing to. And so if 1 over n to the 3/2 converges, 1 over n to the 3/2 plus 4n to the 1/2 will also converge. So that will be convergent by the comparison test. All right, let's come over here. All right, this one again looks kind of strange, doesn't look like things we've talked about. I can't stress it enough. I really have not done a great job in a lot of these videos just because a lot of these have looked so much like things we've talked about a lot. Look at what the nth term approaches, okay? As n goes to infinity, a half times a half times a half times a half times a half, that's going to approach 0. But you're always having 3 plus whatever this other thing is for each term. So your first term is going to be 3.5, and then your next term is going to be 3.25, and your next term is going to be, 3.125, and then 3.16, and so on. But you're always going to have 3 and something else, okay? So over time, your individual terms are approaching 3. If you just keep adding 3 on to infinity, your series is going to add up to infinity, okay? That is a divergent series. That is an nth term test problem. Okay, last one here, and I think I'm running out of time to do this one justice. This looks kind of like the harmonic. You can factor out a 4 here. You've got 1 over n plus 3, okay? Looks kind of like a divergent harmonic. The only problem you're going to have here is this is a case that has the terms are less than the terms of a series that we think is divergent. Okay, so technically we can't use the comparison test here because if we have a series that diverges, a series that's smaller than it might converge. Okay, this would actually be a limit comparison test. You would take the limit of this term over this term, and I think you'd end up, when you divide that, you'd end up with n over n plus 3. That limit would end up approaching 1. Remember, the limit comparison test says if the limit as n goes to infinity approaches a constant, both series do the same thing. So 1 over n is divergent. That means 1 over n plus 3 is going to behave basically like a multiple of that series as you go out infinitely far. It is going to be divergent.